Our focus standard for this lesson continues to be from grade 7, Expressions and Equations, Standard 1. Apply properties of operations to factor and expand linear expressions. The topic comes from our Simplifying Expressions and Equations, Factoring Expressions. Our essential question is, how can we use the distributive property to factor expressions? Please take a moment, pausing the video if you need to copy the topic and essential question in your header along with today's date, set the question column and your note column, and resume the video when you're ready to begin. So you may remember from our last video that we were talking about the distributive property and we were using it to expand those into equivalent expressions. Today we're going to be reversing that process, finding factors, and using the distributive property in reverse to write an equivalent expression. Let's go ahead and begin. So when we're factoring expressions, it's the reverse of the distributive property. So the key is going to be to find the greatest common factor between all terms. So let's go ahead and take a look at our first example. Alright, so in example A, we have the expression 16g plus 12. The first thing we want to figure out is of the values 16 and 12, what is the greatest common factor? What is the largest number that can divide evenly into 16 and 12? If you said 4, I'd agree with you. And so what we're going to want to do is set up something that looks like an expression would before we do the distributive property. So if you remember that when we were using the distributive property in the last video, we had a factor outside of the parentheses and an expression, a smaller group inside the parentheses. So our goal is to say, well, if I know that 4 is the greatest common factor of 16 and 12, I'm going to pull the factor 4 out, and I'm going to simplify this expression using the values I would multiply by 4 to make an equivalent expression. Here's what I mean. Let's start with the term 16g. So what times 4? You can see I already have the variable g here, so we just have to worry about the number 16. What times 4 equals 16? Well, 4 times itself, 4 times 4 equals 16. So we can rewrite this as 4g, because 4 times 4g equals 16g. Alright, and what about plus 12? This constant positive 12. Well, you can notice that I kept the plus sign, the addition sign here. So now we just need to fill in what times 4 equals 12. You said 3, I'd agree with you. So now we've taken the expression 16g plus 12, and knowing that the greatest common factor between those two terms is 4, we rewrote it as an equivalent expression going in the opposite way. Alright, let's try the next one. Alright, example B, 18h subtract 72. So again, the first step is going to be to come up with the greatest common factor between 18 and 72. The factor I was thinking of is 9. So how are we going to set it up? Do you remember how this one looked when we first set it up? Do you think you can do that? Well, since 9 is our factor, we're going to write that outside the parentheses. And we're going to put parentheses The first term has a variable, the variable h, so we know we're looking for some number times h, and then what number times 9 would equal 18? Well, 2 times 9 equals 18, so that'd be 2h. Keep the subtraction sign, and what number is going to go here? Well, what number here times 9 equals 72? You filled in 8, I'd agree. So we took the expression 18h subtract 72, and we factored out a 9 and rewrote the expression as 9 times the quantity of 2h subtract 8 by using the reverse of the distributive property. And of course, you can always check it by using the distributive property, and you should come up with this original expression here. Alright, one more. Here is our last expression. We have negative 24c subtract 15. Go ahead and see, pausing the video, if you can find the greatest common factor and set up an equivalent expression using a factor times a quantity in parentheses that would be equivalent to negative 24c subtract 15. So I focused just on the fact of 24 and 15, and I found the greatest common factor to be 3. So then I set up my parentheses to look like this. 3 is my greatest common factor, so I'm writing it outside the parentheses. I have the term with the variable c, where I'm looking for the coefficient in front of the c that when multiplied by 3 will equal negative 24. And I do have to keep in mind that 24 is negative. I then kept the subtraction sign, and I then have to come up with the constant term that when multiplied by 3 is going to equal 15. So if you haven't gotten this far yet, go ahead and set this up and think about what are we going to put in there, what values are we going to put in those blanks. Well, I would say that the coefficient in front of the variable c here should be negative 8. Because negative 8 times 3 equals negative 24. And for my constant term, I would fill that value in with 5. Because 5 times 3 equals 15. So today, we learned to factor expressions by reversing the distributive property and using the greatest common factor. Please make sure that you have all 3 examples written down, that if you have any questions, you write them in the question column, and come ready to discuss more problems like this in class.